Hey everyone, and welcome. Today we've got a really fun one for you. It's a viral math problem that looks like it was ripped straight out of a Math Olympiad. The challenge? Solve for t in 2 to the t equals t to the 32nd. Now I know, at first glance it seems completely impossible, but it has this surprisingly beautiful solution just hiding under the surface. So let's dive in.
So here it is in all its glory. 2 to the power of t equals t to the power of 32. Just take a second to look at that. You've got the variable t as both a base and an exponent on opposite sides of the equation. I mean, seriously, where do you even begin with something like this? It's a real head-scratcher.
And you know what? That's kind of the whole point. Problems like this are designed to look impossible. They're not just testing if you can crunch numbers. They're testing if you can look at a problem from a completely different angle. It might seem like a brick wall right now, but trust me, we're going to break it down together.
Okay, so every good puzzle is kind of like a locked box, right? You just need to find that first key to get the mechanism turning. For this puzzle, our key is a little bit of clever algebra. We're going to start rearranging this equation to get it into a shape that's way more helpful.
This right here is the first crucial sequence of moves. We start with what we have. 2 to the t equals t to the 32nd. First thing we do, we raise both sides to the power of 1 over t. On the left, that's great news. The exponents cancel out, leaving us with just a 2. On the right, we now have t to the power of 32 over t. For our next move, we raise both sides to the power of 1 over 32. And bam! This gives us our new transformed equation. 2 to the 132nd equals t to the 1 over t.
And this is brilliant because it gives us a super clear goal. Just look at the right side of our new equation, t to the power of 1 over t. Let's call this our target form, x to the power of 1 over x. Our entire mission now is to take the left side of the equation, that 2 to the 132nd, and somehow make it look exactly like that.
And now we get to the real secret of the puzzle box. We have our target, we know what the keyhole looks like, we just need to shape our key to fit the lock. And this is where a really clever little trick comes into play.
Okay, so this is our key, 2 to the power of 1 over 32. This is the piece we need to change. And remember, the goal is to get the base number and the number in the denominator of the exponent to be the exact same. Right now we've got a 2 and a 32, not even close. So how do we fix that?
So how can we possibly change how this thing looks without actually changing its value? Well, we use one of the oldest tricks in the math book. We multiply by 1, but, you know, a very specific, very fancy version of 1, 2 over 2. By multiplying that exponent by 2 over 2, we can start to move the pieces around.
Let's watch this in action. We take our exponent 132nd and we multiply it by 2 over 2. Now, using our exponent rules, we can group the 2 to the 2 together to make our new base, which is of course 4. And what's left over in the exponent? 1 over 64. So 2 to the 132nd is the exact same thing as 4 to the 164. Pretty cool, right? We're getting closer. Now we have a 4 and a 64. Now, what's really interesting about this is that this isn't some one-off magic trick. It's a pattern. It's a repeatable process that's going to walk us right to the solution. We can just do it again. So we take our new expression, 4 to the 164th, and we do the exact same thing. Multiply the exponent by 2 over 2. We group the 4 squares to make our new base, which is 16. The exponent now becomes 1 over 128. You see the pattern, right? The base squares and the denominator of the exponent double. We are so close now, you can almost feel it. Let's just do it one more time. We take our 16 to the power of 1 over 128. We apply our trick. The new base is going to be 16 squared, and the new denominator is 128 times 2.
And there it is. 16 squared is 256. The exponent is 1 over 256. We did it! We successfully manipulated our expression into that perfect x to the x format. That is the sound of the puzzle box clicking open. So we've perfectly reshaped the key, and now it slides right into the lock. All the really hard work is over, and believe it or not, the solution is now just sitting there, right in front of us. Remember our transformed equation. The left side is now 256 to the 125th, and the right side has been t to the 1 over t this whole time. When you just put them side by side like this, well, the answer becomes incredibly obvious, doesn't it?
I mean, if 256 to the power of 1 over 256 is equal to t to the power of 1 over t, then t has to be 256. And that's it. That's our solution. How beautiful is that?
But hold on, we're not quite done. Any good mathematician, any good puzzle solver really, knows you always check your work. So let's inspect the treasure we just found and make sure it's the real deal by plugging it back into that original equation.
So this is the big question, right? Does t equals 256 actually work in the original equation, 2 to the t equals t to the 32nd? Well, there's only one way to find out. Let's do it.
Okay, let's walk through the proof. We substitute 256 in for t. Now, the key move here is recognizing that 256 is just 2 to the power of 8. So we rewrite the right side as 2 to the power of 8 to the power of 32. Now, using our exponent rules, we just multiply 8 by 32, which gives us 256. And there you have it, 2 to the 256 on the left, 2 to the 256 on the right. It's a perfect match. The solution is correct.
And that is how you crack this amazing puzzle. It's just a fantastic reminder that sometimes the most intimidating problems aren't about brute force calculation. They're about finding a hidden pattern, about finding a new way to look at things. It really makes you wonder, doesn't it? What other impossible problems are out there, just waiting for the right perspective to unlock them? Thanks for joining me.